Here's another concept that's not usually familiar to people who aren't familiar with the Schillinger system. This idea of expansion. Now, in his special theory of harmony, this becomes particularly relevant because he argues that, in traditional harmony, when we think of how do we compose chords, we take a pitch scale, like a diatonic scale or whatever you're working with, and we stack thirds in that scale. If we're dealing with C major, we go C, E, G. For a triad, if we wanted to make a seventh chord, it's C, G, B, so we stack an additional seventh and so forth until we get to the 13th chord, at which point we've used all the notes from that scale. So in Schillinger's system, basically what he says is happening there is that we're actually taking the scale and we're putting it into a state of expansion. And it kind of means what it sounds like. It means that the notes in the scale are moving farther apart. They're expanding, they're widening out. To illustrate this, here's a C major scale. I made the center note the axis of expansion a little bit longer just so it's easier to see. So this is the C major scale and it's a state of zero expansion. It's just a C major scale, so a D, E, F, G, A, B, and then C, and downward C, D, A, G, F, E, D, and C. So as you can see, when we expand it, each note sort of moves apart by 1 degree. So the first state of expansion is D moves to E, E moves to G. So they're spreading apart by 1 degree. Now the effect is obviously the same as if you stacked thirds, but conceptually it's just a different way of looking at it. So this is the C major scale going up and down. Again, when we talk about expansion, we talk about doing it about, it's the same as inversion where we have an axis and things expand out from that point. So if this is our C, and this is a C above and a C below, as you can see, we now have, in our first state of expansion, we have a C13 chord. Well, a C major 13th chord to be more precise. So C, E, G, B, D, F, A, and then C again. And the same thing going down. That's just in the other order. So you can continue this as far as you want, really. So he would call this, in Schillinger nomenclature, he would call this E sub 0 because there's no expansion. This would be E sub 1 because it's in the first expansion. And then if we wanted to go to chordal harmony, we'd be in E sub 2 because we're in the second state of expansion. So the notes have moved yet 1 degree farther apart. So it is C, F, B, E, A, D, G, and C again. I put in that redundant C just to show where the whole scale goes. So this is this idea of expansion. Now Schillinger also allows for the fact that, if you want to, if things are moving too far apart, you can constrain the octaves by, if you've got a part, this is all in well for just a scale, but obviously if you have a part or chords or a progression or a melody or whatever that you're going to be expanding, you might want to limit the octave range so that things aren't getting too wide. If you had a melody that encompassed an octave or lay within an octave range and you put it under expansion, that melody now occupies 2 octaves of range. If it's in expansion 1, it occupies 3 octaves of range if you're in expansion 2 and so forth. So things can quickly get very spread out. So the expansions are covered down here under inversion, which I just covered. This first variable in this section here. So this first variable here is, as you probably guessed, an off-on variable. So 0 is off. It's been off for the duration of this presentation. The axis is the axis of expansion. So if you're looking back at this visual representation here, the axis would be whatever pitch you don't want to move. The expansion factor is that E level, and as you see, I commented here to show that. Expansion constraint is a number of octaves that you want to confine, a number of octaves from the expansion axis that you want to confine the entire results to. So the note equivalency will remain the same, meaning if you've got a D, right, and you've now put it in, and you set this to 2, you'd now be in the second state of expansion. So your D would be now an F. Now that's fine here. That's you haven't really changed the range very much. What if you had a B in your melody? Well, that B is now, going to be this G up here. So if you set this at 0, it's not having an effect. The code just sort of says if this is not 0, then it starts doing something. So say you wanted to keep this G within the first octave. You'd say you want to constrain it to 1 octave. If you were okay with it being maybe this G up here, which is about an octave and a half up, you could constrain it to 2 octaves, and that would keep that in that bound. Let's just set it to 0 to see what the actual effect is. So I'm going to turn this on. And so what am I actually expanding here? I've got my sequence of notes here. So one remark about this whole expansion process, because this is a diatonic phenomenon, again, you're expanding a pitch scale, a defined pitch scale. In this case, in our visual example here, it's C major, but it can be whatever scale you want. Because it's diatonic, you need to define what the scale is. And I pointed to this variable here earlier, but I didn't. I told you we would come back to it at some point because it was just not really applicable to what we were talking about at the time. So what this scale does is it defines the scale that we're working in. Now, up until now, the processes haven't taken this into account. It didn't really matter what scale you were working in. You were just working with whatever notes you wanted. At this point, the expansion function really needs to know what scale you're in. So what this scale does is you define the basic unit scale, and the program behind the scenes, I won't show you the actual code, it's not important, but what it does is it then creates an entire scale that it maps throughout the MIDI note range that represents this. So essentially it duplicates this in octaves throughout the range. You can see in the debug code here, as you run the program, usually one of the first things it spits out is this thing, full generated scale. So what it's done here is it has taken, as you can see, I've defined it as 0, 2, 4, 6, 7, 9, 11. That's a Lydian scale with an offset of 60. We're at C, so C, D, E, F sharp, G, A, B. As you can see, our first part of our generated scale is that, and then it's just successive octaves of that. So it basically fills out the entire range all the way up to from MIDI notes 0 to 127. So it creates that full scale, and then it can kind of know where whatever notes you're dealing with here. So this is where you have to kind of be careful. I don't think you'll end up running into a runtime error or anything if you don't do this, but you really, for the expansion function to work correctly, whatever notes you have, whether it's a sequence or whether it's a nested list of chords, you really want all those notes to be a note that is in that master scale, we'll call it. And that's another reason why I find it's helpful to work with, not writing the literal MIDI note here, like not writing 48, 50, 52, and so forth. Working with offsets, think of this as kind of your axis of whatever you're working with. Because it becomes very easy to cross-check and say, okay, well, yes, this does conform to my scale. So you can clearly see that 02467 here is 02467 is part of that. Even though the offset is different, the offset, as long as your offset is kind of a octave multiple, you can be assured, this is just an octave down from this. So we know that as long as these values are in here, then you're pretty much good to go. Again, this only matters if you're working with the expansion function, because the expansion function is diatonic. So you can do that without it. Again, I don't think it'll run into a problem, but it might. I can't remember, but it just, even if it ran, it wouldn't work as expected, because it basically goes through and finds which of these notes are in the master scale, and it won't be able to do that if they aren't actually in the master scale. So I've defined my notes as usual. I've set a scale, and so since we're not dealing with a list, I've turned is chords off. And let's look at what happens. So we turned expansion generation on. We've set the axis to be 48. And let's do an expansion factor of 1. So we're just in E1. Well, let's play it first without the, even with it on, if I set an expansion factor of 0, it's not actually doing anything. Oops, sorry. I forgot that my next function was on, and I'll go over that in a second. So as you can see, it's just playing through my sequence. Nothing has changed. Now let's expand it by 1. So we were just dealing with, it was just stepping up in seconds, right? So our melody is just 02467 in C Lydian. So now in our expansion factor of 1, we should start hearing thirds, right? We should start hearing like an arpeggio, like an arpeggio in that key or mode. So you can see that it worked just fine. Now let's do expansion factor 2. So you can see it did play this kind of more chordal sounding arpeggio. As you can see, that high note started getting pretty high. So let's constrain this. Let's constrain it all to 1 octave. So as you can see, it transposed those last couple notes to be within an octave. Now you can use this on melodies, or you can use it with the chords too. So let me set it back to expansion factor 1, so we're in E1 in Schillinger terminology. Let's turn this one off, and we'll go back to these chords, which again, if we look, let's do a little quick check. So 269, 269, we have the, or sorry, yeah, 269, we have 269 in our original scale, 7, 11, 2, we have those, and 0, 4, 7. So all our notes and our chords are within our scale. Different offset, but again, that doesn't matter because it's within an octave, so it should work out just fine. Remember, we have to turn is chords on. Let's go back down here. Let's just hear what the chords sound like in expansion 0. Now, even though we're in expansion 0, but the chords themselves were already in expansion 1 in a sense, because they're each triads. So when we play them by themselves, even though they're in expansion 0 as far as the program is concerned, they're still technically in expansion 1. So when we expand these, when we put this in expansion 1, musically they'll actually be kind of an expansion 2. Like you'll hear this very quartal sounding music. Yep. And as you can see, you got a little spread out there because our expansion axis is considerably below the upper tones in the chord. Let's constrain this a bit. Let's do 2. I'm not sure if that will change anything. Yeah, so that's they weren't that far apart. Let's do a 1. Yeah, so as you can see, did the same thing. The note values didn't change in terms of, the letter note name of the whatever note it was playing was the same as if we hadn't constrained it, but it just kind of constrained it to a certain octave. So there was some octave transposition going on there. Okay. Let's turn these all off. The next type of expansion, there's 2 types of expansions in the Schillinger system. One is that what I guess I would call tonal expansion. I don't think he uses that. I think that is his term actually. And then there's geometric expansion. So you remember when I talked about inversion, we talked about geometric inversion, which is a strict flipping of the notes. And I use the term tonal inversion, which I definitely don't think is a Schillinger term, but that's just, what I mean by that is diatonic inversion. So here we have tonal expansion, and we have geometric expansion. So what's geometric expansion? It's basically the same process, except you're not regarding the pitch scale. So if I created this other visual representation here. So here we've got a chromatic scale. Again, I kind of made the axis note a little bit longer just so we could see it. So this is C going up to C and down to C. In our first state of geometric expansion, basically everything is just moving apart at the same by the same amount, right? So a semitone up becomes a whole tone up, a semitone down becomes a whole tone down. And so in the first state of expansion, you basically turn a chromatic scale into a whole tone scale. And this is one of the interesting things about geometric expansion in particular. Whereas tonal expansion kind of changes the type of harmony that you're dealing with. You're kind of going from secundal music to tertiary harmony to chordal harmony and so forth. Geometric expansion kind of changes the character in a slightly different way. So you go from having a potential chromatic scale to having a whole tone scale. And then in the second state of geometric expansion, you're now at a diminished scale. If you were to continue this on, in the third state of geometric expansion, you'd have an augmented scale. So as you go apart, at first you start basically eliminating the amount of potential notes that you have. I created this other table here just so you could see what's the representation another way. So this is, it should say 0 in terms of the level of expansion. I numbered them just sequentially in order. So the basic chromatic scale, C sharp, D, and so forth, without any geometric expansion. As you move apart, as you can see, now you have C, D, E, F sharp, G sharp, A sharp, C, and then D, E, F sharp, G sharp, A. So you've got, you have half the number of available existing notes. And then as you move even farther apart, you now have C, D sharp, F sharp, A, C, D sharp, F sharp, A, C, D sharp, F sharp, A. And when you move to the augmented one, now you just have C, E, G sharp, C, E, G sharp, C, E, G sharp. The interesting thing happens when you move into geometric expansion 5, where now you've expanded things so far that you actually have all the chromatic notes back again. They're just in a slightly different order. What's kind of interesting is that some of them retain the original note value. As you can see, C sharp is now F, D is now A sharp, but D sharp is D sharp again. As you can see, then A is also A, and F sharp is still F. So it's kind of curious. As you can see, there's a kind of plan there. So every 3 semitones, the notes are actually retained. And in terms of character, you can see that a semitone now has what used to have a semitone now kind of has the character of a diminished fifth. Oh, sorry, I was looking at the wrong one. I was wondering why that didn't seem right. What used to have a semitone now has the characteristic of a perfect fourth. And we used to have a relationship of a major second, now has this kind of third quality to it. So it kind of changes the character. If you have something very stepwise and secundal, it's going to kind of, when you put it into the fifth state of, or sorry, the fifth state of fourth state, that's right, because I'm enumerating these wrong. When you put it into the fourth state of geometric expansion, you kind of go from this secundal type sound to this chordal type sound. As you can see, when you go to the next state of expansion, you end up in this just diminished fifth sort of tritone scale. You only have 2 notes available. Then when you go to one step farther, you end up into fifth territory, where it's almost states 4 and 5. States 4 and 6 are almost similar in that you've kind of traded secundal relationships for instead of a fourth relationship, it's a fifth relationship. Schillinger talks about kind of the stylistic implications of this, but I just want to, I didn't want to talk too much about the system itself and focus on the program, but I just want to point out that, as you can see, I've indicated here, state 1 kind of creates a whole tone sort of flavor from whatever your material is. State 2 kind of creates a diminished 3 creates a augmented, and so forth. So you generally won't be going much beyond this. As you can actually see, when you go beyond that, you actually start encountering the same things, but just in sort of inverse, like the order changes. When you get to state 10, again, I'm enumerating these wrong, but as you can see, you actually end up, in terms of the actual note relationships, you've retrograded this scale. So CB A sharp A. So beyond this point, you're just kind of flipping things. So the most relevant states of geometric expansion are here. So at state 1, let's turn this on. Same thing as usual. So let's play it off just to refresh ourselves. Okay, so this is like kind of Lydian thing. Let's turn it on. And we're at geometric expansion 1 now. As you can see, character changes quite a lot, and we can hear that sort of whole tone flavor because the only available notes are in the whole tone scale. It doesn't matter what our starting material was; it kind of takes on this whole tone character. We've got this octave constraint again, so let's kind of constrain that to rein it in a little bit, because as you can hear, it got pretty wild there. So same type of character. Let's hear state 2. And you can hear that diminished flavor. Let's hear this augmented sound. Definitely clear that it's, that we've only again got 3 potential notes instead of 12. Now we're in state 4, so we're in chordal territory. We've got access to all of our 12 notes again, but the relationships are gonna change. Yeah, let's widen this a little bit, because it is chordal, but because they're being squashed into an octave, it almost sounds like you're getting these tone clusters. Because yeah. Yeah, so pretty, there's some interesting potential in this this idea of expansion. It's something that, again, people who aren't familiar with Schillinger haven't really explored much, I find.